Good morning, everyone. My name is Holly Reuser with Graybar, and I would like to welcome you to Graybar's G2 Talk presentation on how power is the new signal. We've got a great discussion lined up for you today, but before we get started, I'd like to cover just a few housekeeping items. First of all, if you are one of the first 50 people who joined in on this presentation, you will receive a coupon at a national coffee chain, courtesy of Graybar, as a thank you for your time today. At the bottom of your screen, you'll notice a box for questions and answers. Feel free to submit questions throughout the presentation. We'll address as many questions as time permits at the end of the presentation. Lastly, our G2 Talks are all archived on graybar.com, so you'll be able to view this presentation again or recommend it to others. We're happy to be teaming up with Belden today. As a distributor, Graybar works alongside Belden to help contractors and data center professionals prepare for their networks for the future with new products, solutions, and deployment strategies. You can visit graybar.com to learn more about these solutions. At this time, it's my pleasure to introduce today's speaker, Ron Tellas. Ron joined Belden in 2016 to help define the roadmap of technology and applications in the enterprise. Ron is a subject matter expert in RF design and electromagnetic propagation. He represents Belden in the ISO WG3 committee and TIA TR42 premise cabling standards, and also serves as the editor of the revision to TIA TSB 184 guidelines for supporting power delivery over balanced twisted pair cabling. Ron is also the inventor of 16 U.S. patents. So without further delay, I would like to turn the presentation over to Ron. Take it away, Ron.
Thank you, Holly, and thank you to everybody that took time out this morning to join me to talk about power is the new signal. What we're going to talk about today is what is driving the need for power delivery efficiency by looking at current trends, mainly the evolving LAN, how WAPs are enabling the new LAN, and important facts to know about them. A brief review of important transmission parameters of cabling will also be reviewed, and how power delivery efficiency fits in. Then we'll talk about how to be ready for the future. What skills and equipment will be essential to support the new LAN. And then finally, we'll have a quick wrap-up of recommendations and a question and answer session. As the range of PoE applications is increasing, the penetration of PoE-enabled devices is also increasing rapidly. In a recent study, visually detailed the PoE adoption rates in various applications. By 2020, more than 90% of desktop phones will be powered by PoE. More than 80% of wireless access points will also rely on PoE. And other applications such as access controls, lighting, security cameras, and such, those also see increasing rates of usage of PoE. It is not a surprise that PoE penetration coincides with the convergence uptake in enterprise applications. Today, LANs bring all kinds of traditionally separate standalone systems together under one network. For this reason, the number of devices connected to LANs now outnumber the number of people connected to the LANs. With AV systems, security cameras, and building management systems becoming part of the network, the number of connected devices continue to multiply. Mobile or wireless connections now outpace the number of wired or fixed LAN connections, which has also transformed the enterprise network. With more devices being brought into work and more employees using mobile devices as their primary connection to the LAN, there's a higher demand in performance and increasing the requirements for wireless LAN infrastructure. PoE, as we all know, power over Ethernet connections are increasing as well, meaning that LANs have adjusted their power capacity and port growth to support data and electrical power through the cable. With number of devices outnumbering the number of people, The number of mobile connections is outpacing the fixed connections, and power over Ethernet-enabled connections are exceedingly being powered by local power connections. There is literally a new type of network on the rise. Network speed is increasing, as well as the number of wireless users. Back in 2010, LAN switch port shipments were divided in half being 100 meg and the other half being 1 gig. Today, almost 3/4 are 1 gig, and the average speed is steadily increasing from an average just above 1 gigabits per second to about 2.5 gigabits per second expected in 2019. This increase is driven by the deployment of multi-gigabit wireless access points. In comparison to the data center average speed increase, it may seem small, but in reality, it will necessitate a major networking and cabling upgrade. So I have a quick poll question for everybody. The question is the evolving LAN happening in your enterprise? What do you see in terms of the number of wireless versus wired connections? There's 3 answers. 1, most of the new connections being deployed are wireless. Second, an equal number of wired and wireless connections are being deployed. Or thirdly, most of the new connections being deployed are wired. If you would take the time to answer the poll question, we'll take a look at the results here in about 10 seconds. Okay. It looks like an equal number of wired and wireless connections are being deployed. That's good information. Thank you. Next, I'd like to talk about wireless access point facts. With the wireless access points driving the evolving LAN, it is important to know a few facts about them. We'll take a look at the technical trends, or the technology trends, and then how to maintain throughput, or data speed, when connected wirelessly. First, let's take a look at the path of evolution for wireless access points. As the communication speed to end devices or Wi-Fi data rate increases, the speed of the communication to the LAN must also increase. Presently, the highest speed access point available uses 802.11ac Wave 2 technology. In order to achieve this highest Wi-Fi data rate, the Ethernet uplink speed will also have to communicate at the highest data rate. The wireless access point may also need to have an additional feeder link and higher power to achieve full functionality. To ensure that the wireless access point will operate at full speed and offer all the functions it was designed for, you'll need to make sure your cabling can operate at the higher data rates as well, and that it is capable of supporting the higher power levels. In order to achieve the highest data rate, the user or client needs to be close to the wireless access point. As the client moves away from the wireless access point, connectivity is maintained, but at the expense of throughput or data rate. Today's silicon and advanced digital signal processing, along with channel bonding and multi-input, multi-output technology, referred to as MIMO, a higher density of users can connect wirelessly. But what happens if they all try to download the same content at the same time? The data rate is halved for each user added, and that's what this graph depicts. Now granted, this is a simplistic model, and not everyone is going to demand the same content simultaneously, but this is a good model to show that higher user density will affect throughput. So, with throughput decreasing with distance, and also with an uptick in user density, what does this mean? It means that more wireless access points will need to be deployed in order to achieve optimum wireless LAN speed, or throughput. With the expectation of more wireless access point deployment, we will need to review important parameters of cabling to ensure maximum throughput. We will review information capacity and also power delivery efficiency. The reason that power delivery efficiency is a new parameter is because the new LAN is going to use more wireless access points, which is likely going to be powered with PoE. So network performance, but specifically cabling performance, has been measured historically in terms of information capacity. Cabling performance must also now include power delivery efficiency. Power delivery efficiency becomes very important for higher power PoE systems. This is another reason to seriously consider higher performance cabling solutions as power is becoming the new signal. Simply put, PoE offers rapid and low-cost deployment of efficient and smart power delivery throughout the enterprise. Let's take a closer look at information capacity. Information capacity is the area bounded by the signal power, which is the curve on the top, and the noise, which is the curve on the bottom. So it's the area, that blue area in the middle. This is also called signal-noise ratio and is expressed in dB. So what can affect your signal-noise ratio or information capacity? Well, one thing is the external noise can reduce information capacity. As the noise gets greater, the graph moves to the left and reduce the area of your information capacity or signal-noise ratio. So this added noise reduced the signal-noise ratio. So what are some sources of this noise? Well, one of them is a proximity to power cables, or proximity to fluorescent lights, proximity to ballasts, which power the fluorescent lights generally. And then in higher speed systems, 2.5, 5 gig, 10 gig, noise coupling with other cables is another source of noise. Sometimes this is referred to as alien crosstalk. Insertion loss, or the upper boundary of this area, can also reduce signal-noise ratio as the cabling becomes more lossy. The areas decrease and the signal-noise ratio is also decreased. This can be attributed to higher temperatures, poor balance. Now you say, how is that? Well, insertion loss is anything. It's not just attenuation. Insertion loss is attenuation and any other factor that prohibits the signal from going from the point where it's inserted into the cabling to the expected output. So if you have poor balance, it could go into a different mode and not get to where it's supposed to go. And also poor return loss. And poor return loss could be from a kink in the cable, or a poorly terminated connector, or some other factors like that. So temperature rise. How does temperature affect it? Well, one of the common practice in the industry is dressing the cables. When you dress the cables, this is a contributor to increasing the temperature, specifically for powering cables. So when you use PoE over cables and you bundle them, when you dress them, that's another chance for the temperature to be increased, as shown by this heat gradient. this is what it might look like. The bundle is put together, and all of them have PoE power or current going through them, DC current, and the cables in the middle can get hotter because the heat can't get out. So as they get hotter, the temperature is going to increase, and that can cause the insertion loss to increase as well, or go down, as shown in this graphic. And it's important to know the ambient temperature plus the heat rise must stay below the cable jacket rating. Now let's look at the new metric, power delivery efficiency. What is it? Simply put, it is a function of the DC resistance of the cabling. What governs this DC resistance? One thing is wire gauge. Wire gauge is the diameter of the conductor wires in the cable itself. What is the relationship? As the wire diameter goes up, the DC resistance goes down. Another factor that can govern cable resistance, DC cable resistance, is the temperature. The relationship is, as the temperature goes up, the DC resistance also goes up. So what does this mean? Well, if we look at the different types of, or different gauges of cabling available generally in data cabling, we can see that it's more efficient to use larger diameter conductors. The graph on the top is 22 gauge wire. Is cabling using 22 gauge wire. The second one is using 23 gauge wire. The third one down is 24 gauge wire, and lastly the one on the bottom is using 26 gauge wire. As you can see, as the power goes up, the PSE is the power supplying equipment. As more power is expected to go through the cable, the current goes up, and that causes more power loss through the cable, and that's where the efficiency comes through. So if we keep the DC resistance down, we're going to be more efficient. For example, if I have 60 watts of power being delivered with a 23 gauge wire, I can expect around 84 or 85% efficiency. Whereas if I was to use 26 gauge wire, we would be well below 70%. So you increase the wire diameter, you decrease the DC resistance. Or another way of saying this is bigger wire diameter means better efficiency, power delivery efficiency. Let's take a quick look at the temperature relation to DC resistance. The resistance of the cabling, as temperature goes up, in this case from 20 degrees Celsius, which is room temperature, up to 60 degrees Celsius, which is normal jacketing rated temperature, but there are some cables with jacket ratings of 75 and 90, and I showed those as well. And you can see that, again, the larger diameter wire, 22 gauge, is the bottom one. The resistance can go up, this is per 100 meter, can go up roughly 1 ohm per 100 meter, which isn't a lot. But if we look at something smaller, like 26 gauge wire, which is the one on the top, we can see a dramatic increase of almost 2 ohms, and this is at 60 degrees C. And that's related to efficiency as well. So when we're bundling cables, what do? There's a good mitigation strategy out there, and that's what I'm showing here in this graphic. The one on the top is a large bundle, and I'm showing the temperature gradient, showing the ones in the middle being very much hotter than the ones on the outside. If I take that bundle and I split it up into 3 bundles but still keep them together, I get the pattern on the bottom left. That will reduce the cable heating by 25%. If I was able to take those bundles and separate them, let's say by even 1/4 of an inch, as shown on the bottom right, I can reduce the cable heating by an additional 30%. That's half of the temperature rise that the cables at the top would see. So a good mitigation strategy to combat added temperature rise from bundling cables under PoE load is to keep your bundles small and separated. Why is this important? The new LAN likely requires more wireless access points in order to maximize wireless connectivity or throughput. A floor once covered by 30 wireless access points, shown on the left, will need 60 wireless access points to maintain throughput as the floor is used by more users, shown on the one on the left. When deploying wireless access points and cables are added, utilize cables that maximize information capacity, maximize power delivery efficiency, and also minimize the bundling. What's the best choice for this? Cat 6A. Generally, Cat 6A is 23 gauge, and as the switch speeds increase from 1 gig to 2.5, 5, or even 10 gigabits, it will be able to connect to the wireless access point to the LAN at the highest speed, and will be less affected by noise from other cables or alien crosstalk as well. As stated in the abstract, there is a new LAN deployment strategy called Direct Connect. So Direct Connect is a good strategy to make yourself ready for the future and maximize your power delivery efficiency and information capacity. If you're going to deploy wireless access points in a brownfield scenario, or one where you already have wired connections, you're likely going to have to move from the wall connection up to the ceiling. This is because most of the time the installed cabling were predominantly deployed for desktop devices rather than for access points. So in other words, most cables behind walls, instead of being above ceiling, or in other words, most of the cables are already behind the walls, but need to be moved up to the ceiling. So you're going to need new cable runs to be deployed in this case. You can also pull them through the ceiling. There's a benefit for using the home run, end-to-end, or direct connect cabling. Direct connect cabling is a good way to have efficient power delivery and minimize insertion loss. That is because we're using horizontal cabling all the way to the static end device. To support the move from the wall to ceiling, you might want to consider grid cabling for ceiling infrastructure. This is where horizontal runs are pulled to the zone boxes, and within these zone boxes are panels. Assemblies are deployed from these boxes or panels to the connected devices. These endpoint devices can be the wireless access points, but as the LAN takes on more and more other network connectivity, it can take on lighting, displays, monitors, everything. Since things can be added or moved, only the assembly from the box to the static end device will need to be changed. Using Direct Connect with grid cabling will bring the same benefits as using a Direct Connect assembly straight from the equipment all the way to the end device. And if you're also using grid cabling to future-proof yourself, you should install more runs than you need now, so that you're ready to add in more static end devices in the future. I'd like to take a second to have another poll here. The poll is, do you see a benefit in using direct connect cabling? So if you could answer with either I see the benefit, I do not see the benefit, or lastly, I need more information, please answer now. Now I'll give you a few seconds here to gather your thoughts and answer. Wow. Most everybody sees the benefit. I'm glad you do, because I think this is a really good approach to make sure that we have the highest information capacity and best power delivery efficiency. All right, so what's important to know about direct connect assemblies? Well, first off, to deploy direct connect, plugs will need to be installed in the field onto horizontal cabling. There are two types of field plugs available in the market. It's the crimp-on type shown on the left. These are usually made entirely of plastic molded parts. The plastic molded parts are intertwined and connected onto the cabling, and then lastly crimped onto the cabling. The other type is a PC board type. This has a PC board on the inside, and the back end is an IDC, or insulation displacement contact, which pierces through the jacketing of the insulation of the conductors, and then makes the connection to the PC board in that fashion. Both of them work equally as well. I want to make that point clear. Both of them work just fine. But it's important to only use plugs that are designed for your cabling. Why? Because a plug must have a certain amount of crosstalk so that the next performance will be achieved for the permanent link or channel when mated to the connector. This is an important point. I'm going to take a little time here to really kind of go over why this is important. So here is a range of crosstalk that a plug is supposed to have. This is the amount of crosstalk a plug must have in order to work properly when mated to a connector. If the plug is mated improperly, or you do a lot of untwists, or you use a 5E on a Cat 6A cable, for instance, you would probably end up with a plug that would be considered low performance or far to the left. If you had a plug that you put extra twists into and had very little crosstalk in, you would have something that's called a high performance plug, which is on the right. You don't want to be at those two extremes. You want to be right in the middle. And for 5E, you want to be between 35.8 and 39.5. The numbers aren't really important. You just have to know that it has to be within a range. And if you're going to Cat 6 and 6A, this range is even smaller. So how does this range get smaller? Well, let's go back one slide to this the field plug types, and look on the crimp-on type. Look at the piece in the middle on the 5E. Everything is in line, they're straight. And if you go down to that same piece in the middle on the Cat 6 or 6A, the channels or the holes that the wires would go through are not straight. They are zigzagged. This zigzag allows there to be less noise introduced onto the from the plug, and that's how they narrow up the range of. That's how they narrow up the range of the plug performance. So the plug must be in range to meet the next requirements. That's called. This is so that you have interoperability, or you're able to connect any type of plug. And let's say I want to have a high performance plug and I'm far on the right. You might think that higher performance is much better than having something that's lower performance or even in the range. In actuality, if you have a high mated next or a high performance plug or a lower performance plug or any kind of plug that's outside the expected range, you are not going to meet your next performance. The next will be out of range. They'll both be high. They'll have high necks, which is not what you want. So you have to be within range. So how do you know you're putting these plugs on in the field? How do you know if they went on properly? Well, you test them. Here's an important fact to follow if you consider direct connect. You cannot measure this using channel specifications on your field tester. So if I put a field test in the field, if I make a direct connect and I put my direct connect plug straight into the channel adapter and then test it, I am not going to know how good that plug is. That is because using a channel adapter, it subtracts out the connector and the plug that are mated inside the channel adapter. The channel specifications do not include the plug on the end of the channel. Since direct connect will likely use field attached plugs, a slight modification to a field test is needed, and that's shown here in this graphic. You're going to need a small pigtail with a connector, and then you can test in channel. This would add in an extra connector into your channel measurement. Or you can use permanent link adapters as shown here with a coupler, with a really good coupler, and then you put in your direct connect assembly, which is number 5. Alternatively, you can use ISO limits available on some testers labeled. This test is TR 11801-99-2. It's not a spec yet. It's going through the balloting process. It utilizes patch cord adapters, but does the calculation to include the plug on the end of the channel. So if you have a tester that can perform this test, you would set it up in this configuration, where we have a patch cord test head on each the main and the remote unit, and then in the middle is the direct connect assembly that had field attached plugs on each end. And then you would test it, and this would ensure that your direct connect assembly will meet the next requirements. It's very important to remember that the plugs must be designed for use with cabling. I'll go back to this slide again. You cannot put a 5E on a Cat 6A cable and expect to have the performance that you want. The other thing too, you have to why it's important to make sure that the plug is designed for your cable is that the different gauges of cabling have different diameters of the jacketing over the conductors, and in some cases these diameters might be too large to fit into the plug. And then as you go to Cat 6 and 6A type plugs, it's going to be even more important how these conductors lie in the crimp type, because that's part of the next at the crosstalk that the plug brings. The PC board type has IDCs on the back, and it disengages the cable from being part of the plug crosstalk, because all the crosstalk is in the PCB, and the end of the plug is terminated with IDCs. So I make a direct connect assembly, I put my plugs on, and I test it. What does that test look like? Well, the test limit is called out. It's also called end-to-end. Right now, it's a link model and limit It's a TR technical report 11801-9902 that's being developed in the ISO IEC community that is going to become a spec under ISO IEC 14763-4. That's coming up. It's going to be sometime next year. But for now, these test limits are available for use, and will ensure, if you use these, will ensure that the field attached plug will achieve the next performance that you expect. And I put on here the test limit names of a particular brand just so you understand how to select it. It's not very straightforward. So I have one more poll. Do you have the equipment needed to properly test a field terminated plug? This is very simple, yes or no. Or lastly, I do not attach plugs in the field. And I'll give you guys a little bit of time to go through it. All right, let's take a look. Looks like almost half of you have the equipment needed to properly test a field terminated plug. Those of you that don't, I highly recommend that you do. You can use your existing field tester by using a pigtail. A pigtail is just a short piece of cabling with a plug on one end and a jack on the other. The drawback of that is that pigtail becomes part of your measurement, but you should have sufficient margin to test that properly and be assured that you installed your field plug properly. All right, so lastly, I'd like to go over some recommendations, just kind of a review of what we talked about. So the recommendations, first off, limit the bundling of cabling. So with PoE, you're going to have current going through the cables. Current through cables brings out, it's called I2R losses. These is the power loss because of the resistance in the cabling. When lots of cables are brought together in a large bundle, the cable on the inside can't dissipate the heat, and so it becomes trapped, and it makes it hotter. This causes insertion loss issues, and also causes your DC resistance to go up, which also affects your power delivery efficiency. Consider the gauge of your cabling. Best benefit out of direct connect is that it uses horizontal cabling, and horizontal cabling is generally a larger diameter cable. So you wouldn't want to do a direct connect with 26 gauge. It's just too lossy, and you're not going to maximize your efficiencies at all. So consider what gauge of cabling you're using. This doesn't really apply to Cat 6A because most 6A horizontal cablings are already 23 gauge cables. So that's really kind of the de facto standard. If you're not sure, you just go 6A and use horizontal cabling in your direct attach or direct connect assemblies, and you'll be good. Like I said, use direct connect for static end device. Since it's a horizontal cabling all the way from the equipment to the end device, you're going to maximize your efficiency because the DC resistance is going to be lowest, and you're also going to minimize your insertion losses because a larger gauge wire has lower insertion loss. Make sure you use plugs that are designed for the cabling. You don't want to put a 5E plug that's specifically designed only for 5E on a Cat 6A cable, a horizontal cable. Number one, because it might not fit, and number two, you're going to have a lot of crosstalk in there, and that crosstalk is too great of a range in 5E for it to be considered for 6 or 6A. Lastly, test your plugs or your direct connect assemblies in the field, and make sure your test method is one that can include the plug, so that you know that you put the plug on properly. I'd like to thank everyone for your time today, and right now I guess we're going to have a little Q&A session. So Holly, I turn it over to you.
All right, thanks so much, Ron. That was an excellent presentation. At this time, we would like to address some questions that we've had submitted. As a reminder, if you have additional questions, feel free to go ahead and submit those as we're going through these. You can do that utilizing that Q&A box at the bottom of your screen. Again, if we don't get to that question, we do answer each and every question. A Graybar representative will follow up with you after the presentation. So we'll go ahead and get to the first question here. The first question that we have is around structured cabling standards, and the question is, does utilizing direct connect violate structured cabling standards?
Well, that's a good question, and the answer is no, it does not, especially if you're using grid cabling, as I'm showing here. You're still bringing connectivity out to a zone box, and then from that zone box, you're going to your end device. So that's still a structured cabling scenario, and the purpose really of structured cabling is to allow you to put things together and be able to change them easily in the future. And in that case, this grid cabling approach does not violate that.
Okay, perfect. Thank you very much. All right, this next question is around a preterm coupler, and the question is, will the Belden preterm coupler work for testing purposes?
I believe the coupler that is being referred to is shown in this graphic right here, which is item number 4. So in this case, a direct connect is used. The direct connect assembly is number 5. The plugs that were just terminated on the end of that direct connect, that will go into a coupler, and that coupler would be fixed on the end of a permanent link adapter. The only challenge here is that you're only going to be able to measure permanent link. So if you wanted to know the channel performance, you would have to download that information and then do a conversion in the software to channel, or you could download it into a spreadsheet type format and then apply the other limits. But if you did a permanent link and you passed permanent link, you're assured of channel performance.
Okay, great. So the next question I'll ask is, do the pigtails being used to test the cable need to match the cable being tested? So for example, UTP, FTP, Cat5, Cat6A.
You know what? That's never really thought about that before, but I think that you would be okay with a mismatch. So you could have a pigtail that's dedicated to being your part of your test. You got to remember though that becomes part of your test. So if you had made a 5E pigtail and you made a 6A type of direct connect, when you did the test and you tested it to 6A performance, and it didn't pass, you don't know if it was because of the plug that you attached or if it's because of your pigtail. The other thing too is to consider is that if your direct attach assembly is shielded, you would want to make sure that you have shield continuity, and in that case your pigtail would have to be shielded as well so that you could do the shield continuity test on field testers.
Okay, great. All right, the next one is referring to your efficiency chart, and the question is it correct to say that an 80% efficiency will result in a 20% power loss?
Well, we have to be careful about how we interpret this. It is true that you'll have a 20% power loss, but it's only, you're still going to deliver enough power to the other end. So if I put in, if you put in 60 watts at the other end, and you only have 80% efficiency, you're going to have 80% of that 60 watts.
Okay. The next question is asked by the same person, and it's in two parts, so I'll try to ask you both of these. If you need me to repeat it, please let me know. The first one is, are the balance measurements on the DSX right now? And then the second part is the test ISO 11801 PL2? If you want to start with the first one.
First question is the balance measurements on the DSX? And
yes.
That's specific to a one particular type of tester, and I believe that they are. The second part of your question was, what was it, PL2?
Yes, is the ISO 11801 PL2.
So PL2, I believe, refers to a permanent link with two connectors. And this is a end-to-end link, so it's not to the permanent link limits. It's geared towards a channel limit. So there's different types of test limits out there, and that's shown on this graphic. There's several other screens on these testers, but there is the different number of connectors. There's 2 connector, 6 connector, 5 connectors, and so forth. So depending on the number of connectors that you have in your channel, along with your direct connect at each end, you'd have to change to a different test limit. So the direct connect takes into account the number of connectors, yes, but it's not PL2 because it's not a permanent link.
Okay, thank you. Ron, another question that has been asked is it possible to get a test plug? Is it possible, and if so, where could they obtain a test plug?
A test plug?
Correct.
Well, test plugs it's not, you mean a field attached plug? Or because usually
sure.
Test means a plug that goes onto a vector network analyzer, and you have to use balance to measure that. So I'm not sure that's what was asked. I think what's meant is where can I get a field terminable plug that can go in horizontal? And I'd like to just say that a lot of manufacturers have those already, including Belden, and in the very near future, we are going to have a whole new type of connectivity that will help assist this type of deployment called Brev Connect. So I would say stay tuned for more information, and ask Graybar or Belden representative for more information, which we have available already.
Okay, great, Ron. Thank you. Another question is about the horizontal run. So if you could address, can the horizontal run be longer if you do utilize a direct connect?
The limit is always 100 meters. So a channel is limited to 100 meters for Cat 5e, Cat 6, and 6a channels. When Cat 8 comes out, that's significantly lower, but that's not going to be widely used in the enterprise, I don't think. But for all the others, it's 100 meter. So you would not really be able to go beyond 100 meters. You might be able to get back the 2 meter that's accounted for in the channel that uses patch cords today. So you might be able to go a little longer, but not significant.
Okay, great. The last question we have today is around the field attached plug. Which type of field attached plug is better, the crimp-on style or the PCB type?
They're both equally as good. The crimp-on type, you have to make sure that the plug is designed for your cable, because the twist rate and the diameters of the cable are part of that plug next performance. So you have to make sure that it's designed for it. But if you have a plug that's designed to go on a horizontal cable, a crimp type works just fine. PC board type works just fine as well. It just has a wider range of cables that it can fit onto, because it disconnects the dependency of the cable geometry, twist rate, and diameter of conductors as being part of that plug next. So it's connected on the back, and then all the required couplings to give the plug next performances in the PC board. So quick answer is they're both equally as good. Just like the PCB type or the crimp-on type, you just got to make sure that they're designed to go onto the cable that you have.
Okay, great. Well, I want to thank you again, Ron, for taking the time. It was a great presentation. We appreciate the questions. I think we were able to answer each one of those. If you had a question that came in just in the last couple of seconds here, we will follow up and ensure that a Graybar representative does follow up with you after the presentation. At this point, as a reminder, the presentation will be archived on graybar.com. That's /G2 archive. Again, thank you for your time today, and we hope you will join us again for next month's Graybar G2 Talk. Thank you.
Thank you.